So the way that we learned the graph inequalities, that strategy of shading up or down based on the inequality symbol, right, where I just look at the symbol and I say, oh, well, if it's this or if it's this, I shade up, and if it's a less than sign, I shade down. So that actually only works when y is by itself on the left. And so that it basically only works in slope-intercept form, like this, right? Like it just works if you have an equation that looks like this, but it doesn't work if y is anywhere else. And so we need another strategy. And so I'm going to show you another strategy, and I think you may find that you even like it better. So you can use it on problems like these too, but it's definitely the one that you're going to have to use on standard form. So the strategy is to decide which way to shade by testing a particular point. And 0, 0 is the easiest point to test, and so that's the point that we're going to be using for the most part. So first, but always first we have to figure out where the line goes, right? So if I'm looking at this, I just have to, right, let's figure out where the line goes by plugging in 0. And as far as the line goes, like I don't need to copy this, right? I can just use an equal sign because I'm just trying to figure out, well, if this was an equation, where would the line be? And so I'll come back to the inequality. So this becomes, so that becomes 0, 4. And this becomes 3, 0. And so what I learned is that I can plot these 2 points, and those are going to be my line. Now, what still works is looking at this symbol and saying whether the line is solid or dotted. And so if there's a line underneath, right, if it's less than or equal to, greater than or equal to, right, if it has that or equal to sign, then it's solid. So I'm going to draw this solid line. And now the question is which way to shade. And so here's how I'm going to figure it out, because this, like, I can't just look at this and be like, oh, I shade down because it's a less than sign. That only works when the y is by itself. So what I'm going to do is I'm going to plug in a point. Now, I could plug in any point. I could plug in this point here and see, okay, does this work? And if it works, I would shade this direction. Or I could plug in this point over here, and if it works, I could shade this direction. Or if it doesn't work, I could shade the other direction. And so I could plug in any point, but you know what the easiest point to plug in is this one, 0, 0, right? Because look, watch what happens when I plug in 0, 0. It's just, that makes the math really easy. This becomes 0, this becomes 0. So I end up with 0 is less than or equal to 12. Now I need to look at that and decide, is that true? Is this statement true? Is 0 less than or equal to 12? Well, it's definitely not equal to 12. But is it less than 12? Well, yeah, 0 is less than 12, right? If I had to choose between having $0 and having $12, I would choose $12. So 0 is less than 12, and so this is true. And so if that's true, that means 0, 0 is possibly a solution to this inequality. Which means the solution, if this is a solution, that means, and remember, like, the solutions are either one side of this line, right? They're either all of this space or they're all of this space. Well, if 0, 0 is a solution, it must be all of this space, all of this side. And so what I do if 0, 0 is a solution is I shade towards 0, right? I shade the side of the graph that includes 0, 0. Let's try another one. Now notice, this one is in y equals mx plus b form, so I could just use my shortcut of looking at the symbol and shading up or down. But I want to show you that this strategy, the plugging in 0, 0 strategy actually works for everything, which is nice. It's nice to have a strategy that works for everything. So I'm going to first graph this line, right? I start at 2. And then here's my slope, my rise over run. Up 1 over 2, up 1 over 2. I look at my symbol. It turns out to be a solid line again. So I'm going to graph my line. And now I'm going to decide which way to shade. And so I'm going to use my strategy of plugging in 0, 0. So I'm going to plug in 0 for y. Plug in 0 for x. And so let's see, this is 1/2 times 0, which is just 0. So this is 0 plus 2, which is just 2. So this says 0 is greater than or equal to 2. Okay, well it's not equal to, right? So the question is 0 greater than 2? 0 greater than 2? Well, no, 0 is not greater than 2. 0 is greater than negative numbers. It's greater than negative 2, but it's not greater than a positive number like 2. So this is wrong. This is false, right? Up here it was true. Here it's not true. It is false. So I don't want to shade 0, 0, right? That is not a solution. So 0, 0 is on this side of the graph. So I'm going to shade the other side of the graph. And now you're going to try.